All right, let's jump right in. Today, we're going to tackle a massive question. How do you build an AI that you can actually trust with something really important, like, say, your money? We're going to break down a blueprint for exactly that using this really cool architecture called Stock Guardian AI as our map. Let's do this.
So first things first, we've got to get our heads around the basic problem here, what a lot of people call the rogue AI problem. And look, we're not talking about your everyday chatbot. We're talking about AIs that can actually do things in the real world on their own. And that, my friends, is a whole different ballgame of risk.
So this is the billion-dollar question, isn't it? If you have an AI that can research stocks, analyze your portfolio, maybe even suggest trades, what's really stopping it from making a disastrous mistake? Or leaking your private info, or even getting tricked by a hacker? And this isn't some sci-fi movie plot, it's a real, tough engineering problem we need to solve right now.
And this gets to the absolute heart of the issue. You see, most AI agents out there are built as what's called a fragile wrapper. Basically, you take a super powerful AI model, put a thin layer of code around it, and just, cross your fingers and hope for the best. The approach we're digging into today, the secure gateway, flips that completely on its head. The AI is just one piece inside a much bigger, much stronger, secure system.
And believe me, the risks with that fragile approach are no joke. We're talking about stuff like a denial of wallet attack. That's where a hacker tricks your AI into a crazy infinite loop, and suddenly you're looking at a massive API bill. Or the AI accidentally leaking your personal financial data to some third-party company. Or, and this is the scary one, it gets tricked into doing something it should never do, like selling your entire stock portfolio because of a hidden command someone snuck into a news article it was reading.
Okay, so how on earth do you defend against all of that? Well, the answer isn't to build a simple fence. You have to build a fortress. So let's shift from the problem to the solution and see what it takes to build an AI system that's designed for security from the ground up. The secret sauce for this fortress is a classic idea from cybersecurity called defense in depth. The whole philosophy is really simple. Trust nothing. Every single piece of data, doesn't matter if it's from you or from the internet, is treated like it might be a threat. It has to prove it's safe by getting through multiple separate security checkpoints. This way, there's no single weak spot. So let's actually see this in action. Let's follow a piece of data on its journey. First, it shows up at the front gate, the ingress layer. But before it gets anywhere near the AI, it hits the scrubbing and audit zone. Here it gets cleaned of any private info and scanned for anything malicious. Next up, the validation zone, where it's forced into a super strict, safe format, which totally neutralizes any hidden tricks. Only then does it get to the AI, which is kept in its own little cage. And most importantly, before any big decision is made, it has to pass one final checkpoint, the verification zone, where a real human has to give the final okay. All right, so we've seen the fortress from the outside. Now, let's go inside and actually meet the guards, the specific security pillars that are standing watch at each of those checkpoints. This is where it gets really practical and, honestly, pretty cool. Every specific fear you could have is matched with a specific engineered defense. So are you worried about that giant API bill? Meet Pillar 2, the budget breaker. It's a hard-coded kill switch that stops everything if costs get too high. Concerned about your private data getting out? Pillar 5, the PII scrubber, finds and removes all your personal info before it can ever leave the system. And terrified of a rogue trade? Well, Pillar 4, the human in the loop, makes that impossible without your final approval. It's a direct counter to every threat.
Now, this is probably the single most important idea in this whole explainer. It's this concept of deterministic controls. See, this isn't about politely asking the AI in its programming, hey, please don't do anything bad. No way. This is about writing code that makes it physically impossible for the bad thing to happen. The budget breaker doesn't ask the AI to stop, it shuts the whole process down. The system doesn't ask the AI to wait for you, the code literally freezes until you type Y and hit enter. It's about building walls, not making requests.
And just so you know, these defenses aren't just random ideas someone came up with. They are systematically designed to fight back against the known threats that are laid out in professional cybersecurity playbooks, things like OWASP and Stride AI. Think of these as the expert guides to all the common ways that hackers try to break into AI systems. This fortress was built to stop them. Okay, this all sounds great in theory, right? A big fortress, a bunch of guards. But how do we actually know it works? The next step is to stop just talking about security and start measuring it, to turn this fuzzy idea of risk into a cold, hard number. This is where you start.
An unprotected, typical AI agent that's connected to the internet has a risk score of 25 out of 25. In the world of security, that is catastrophic. It's an unacceptable, off-the-charts level of risk. It's a ticking time bomb, plain and simple.
And now, check this out. After putting the stock Guardian AI Fortress in place, that catastrophic 25 gets crushed all the way down to a 6. This isn't just a feeling of being safer. It's a quantifiable, measurable improvement.
So, you're probably wondering, where does that number 6 come from? It's not magic. Professionals figure out risk by multiplying the likelihood of an attack by the impact it would have. Now, the likelihood is still a 3, or possible, because hackers are always coming up with new tricks. But, and this is key, the impact is only a 2, or minor. Why? Because even if a hacker gets through, our guards, the budget breaker, the human in the loop, physically cap the amount of damage they can do. The blast radius is tiny. So 3 times 2 gives us our new managed risk score of 6.
And this quote from the systems architect just nails it. By putting a number on risk, you can change the entire conversation. It's not just about building defenses anymore, it's about a strategic plan. The roadmap to get from a 6 down to a 1 is a plan to evolve from just reacting to threats to being proactively resilient.
So, a score of 6 is already really good. But what does that proactive future look like? How do you get from 6 all the way to the Holy Grail, a risk score of 1? Let's take a look at the roadmap. This is where the defense gets really smart. The next generation is about making the fortress intelligent. For instance, automated red teaming. That's like building a second, evil AI whose only job 24/7 is to attack the main system, trying to find weaknesses before the real bad guys do. And then you have semantic drift monitoring. This actually watches the meaning of what users are asking for in real time. If someone's requests start to sound like a known attack pattern, it can raise an alarm before the attack even fully launches.
And that's the end game. A risk score of 1 out of 25. This is basically a secure state. It's the gold standard that every security expert is aiming for, where the chances of a successful attack and the damage it could do are basically 0.
So, when you boil it all down, what's the big takeaway? AI's power is amazing. There's no doubt about it. But what this shows us is that trust isn't something that just happens. It has to be engineered. It has to be built into the very foundation of these systems. And that leaves us with a really important question, not just for developers, but for anyone who uses this tech. What fortress are you building?